Hello and welcome to this Vivado quick take on the basics of running design rule checks, otherwise known as DRCs. First, we'll discuss the definition of DRC, followed up with a recommended methodology overview, and then we'll jump into the demo and show you how it's done. First of all, let's start by defining DRC. Let's see what Wikipedia has to say about DRC. DRC is the area of electronic design automation that determines whether the physical layout of a particular chip satisfies a series of recommended parameters called design rules. Every chip manufacturer has a set of design rules that all designs must abide by. DRC is the method by which you can assure conformance to these rules. The methodology around running DRC can be summarized into 3 simple steps. Always run DRC early in the flow, run DRC after each major design step, including after synthesis and after implementation, and fix critical warnings and errors before proceeding to the next step. With regard to step 1, all checks are available at all times in Vivado. This is why it is generally a good practice to run DRC checks as early in the flow as possible. Do not wait until the generate bitstream step for running DRC, as then you will have to go back through synthesis and implementation if any errors are found. With regard to step 2, it is highly recommended that you run DRC after both of these steps. Synthesis is a major step in the design cycle, as this is where your RTL has been mapped over to Xilinx FPGA gates. Before running the place and route step, you should ensure that there are no critical warnings or errors in your DRC report. Implementation place and route is the final stage before generating a bit stream and programming your FPGA. During this stage, many optimization and replications can take place, and thus it is very important to run DRC checks to confirm compliance before generating a bit stream. Due to the importance of DRC, Xilinx automatically runs DRC before generating a bit stream, although don't rely on this automatic process and run DRC early. With regard to step 3, all critical warnings will be upgraded to errors before generating a bit stream. This is why it is very important to fix all critical warnings in a design before progressing. Errors will stop the flow, and it is very important to start with a clean DRC report before proceeding from one step to another. Now let's jump into the demonstration. In this demonstration, we'll show you how to work with DRCs using Xilinx Vivado design tools. We'll start off by opening the synthesized design. Now that our synthesized design is open, let's click on the Report DRC button to run the DRC check. This brings up the Report DRC dialog box where you have the ability to select the rules you want to run. In this design, we have one critical warning that is marked with an orange exclamation mark. Click on the exclamation mark button to the left to hide non-critical warnings. Right-click on the critical warning and select Validation Properties. This will enable us to view the specific warning message for this error. As it turns out, the critical warning is coming from the fact that not all of the IOs have a valid IO standard set on them. This will prevent the design from being able to generate a bit stream. The error message also lists the ports that have the issue. Now let's go to the XDC and see what's going on. We have assigned an IO standard for the input ports, although we're missing IO standards for the output ports. Let's uncomment this line and save the constraints. Since the synthesized design is out of date, we should reload the design. Now that the design has been reloaded, let's see if the critical warning is gone. As you can see, the critical warning is gone. Vivado also provides the capability to write to a file for users who are not using the IDE. Let's use the Tickle console to see how this is done. Since we want to pipe this to a file, let's add in -file post_synth.drc. You can name the file anything you want. Now let's review the file that got written out and see how it looks. Now that the file checks out, let's run the design through implementation. Since we modified the XDC, Vivado will ask if you want to rerun synthesis to ensure that all of the changes are accounted for. So let's go ahead and rerun synthesis and then start implementation. Now that implementation is completed, let's go ahead and open the implemented design and run DRC. The Report DRC dialog shows that we have 3,050 rules that are available before generating the bitstream. There are a few additional bitstream checks here that are only available after the design has gone through implementation. This is why step 2 of the DRC methodology is so important. Now let's check for any critical warnings or errors. Well, it looks like we're in the clear here, so let's go ahead and hide those non-critical errors. And we're ready to regenerate the bitstream. We should be able to obtain a successful bitstream out of this run since we had no DRC critical errors in the bitstream stage. Now let's take a look at the project summary window under the DRC violations section. Every time you run a report DRC, this dashboard will automatically be updated with a summary count of the various violations. We can also confirm here that there are no errors or critical warnings and that the write_bitstream has been successfully completed. In summary, remember the 3 recommended steps for DRC methodology. Always run DRC early in the flow, run DRC after each major step, and fix any critical warnings or errors before proceeding to the next step. If you follow these 3 simple steps, you will ensure maximum efficiency for working with DRCs. Thank you for watching, and as always, please check back at xilinx.com/training/Vivado for additional Vivado training.